Now let's do some mixed molar conversion practice to show you that if you start on one end, you don't have to just end up in the mole or vice versa. You can actually go through the mole to get to other things. The mole is where everything passes through. So number one, it asks, what mass of helium is in a 329 liter balloon of helium at STP? So we start with what we know, 329 liters. I'm going to remove some of my units to save space. So we just have 329 liters of helium. I'm going to get rid of liters and go toward moles. So we're currently in the blue section where we're going from gas volume into the mole. And we know that 1 mole of any gas is 22.4 liters at STP. But we don't stop there because it asks us for the mass. So currently, we've done this step, and we're currently in the mole. To get to mass, we know we're going to have to multiply by the molar mass, which means we should see the molar mass of helium appear in the numerator position. So let's verify that. So next, we're going to get rid of moles and go toward grams. And that's specifically for helium. So I will put helium here just so we know which element. So we look at the molar mass for helium, and we see that it's not diatomic, it's monatomic. It's not one of the 7 we have to know it appears in a twin or buddy system usually. So 1 mole of helium is about 4.0 grams of helium. We can cancel out the units, and we're left with grams of helium. And that gives us an answer of about 58.75, which we can just round and say it's about 58.8 grams of that helium gas. So that's how we do the first one. Notice how the word moles was not mentioned. We needed to use the mole, we passed through the mole, but we didn't actually need the word mole in the problem because instinctively we should understand that the mole is the goal. Number 2, now how many helium atoms are inside this same balloon? So we can still start off with what we have, which is 329 liters. So we have 329 liters of helium. And we're going to convert from liters of helium to moles of helium using the 22.4 that gets us out of liters into moles. But we have to go now down on our graph. So that means we're going to get rid of moles. And we're going to go to atoms of helium. Now this link here, this dimensional analysis conversion factor we need is going to be Avogadro's number. 1 mole of anything, in this case helium atoms, is 6.02 times 10 to the 23rd particles, atoms in this case. So we can cross out moles, circle atoms, and we're going to get a really large number. And that's also a clue. If you're asked to determine the number of atoms or molecules or something, you're usually going to get a really large number as your answer. So what we're going to have as our answer is about 8.84 times 10 to the 24 helium atoms. So this goes to show that you can start anywhere and get anywhere else as long as you go through the mole. Just make sure you're following the right steps. If you're doing something like homework and you're just trying to get practice into getting the answers, you could use this chart and get them pretty quickly, but make sure that you understand the dimensional analysis that's going on when it comes to doing molar conversions that have more than just one step. Here are some more examples of mixed molar conversions where you have to go through the mole. For the first one, we are given a mass of gold, pure gold, 1,000 grams or 1 kilogram. So we're starting off with mass. And it asks us to determine how many gold atoms are inside this bar. So we would divide by the molar mass to get into moles, and then we would multiply by Avogadro's number to get number of particles. Let's do it. So we start off with the fact that we have 1,000 grams of gold, and we're going to convert from grams of gold to moles of gold. The molar mass of gold is 197 approximately. So grams cancels out. We don't want to stop at moles because we have to keep going. So notice how we got to go from moles of gold to atoms of gold. It doesn't matter if that is gold for this purple section because 1 mole of anything is 6.02 times 10 to the 23rd things. We cancel out our moles and we have atoms. So you can calculate the answer. I'm not going to calculate the answer, but you know the answer will be whatever the answer is, gold atoms. For number 4, we are given a large number, 9.066 times 10 to the 25, molecules of sulfur dioxide gas, and we want to find the volume of this gas at STP as well as the mass of the gas. Mass does not depend on temperature and pressure, but volume does. So to set up for the first part, we are going to need to put the number of particles, so 9.066 times 10 to the 25 molecules. You could abbreviate molecules as MOLEC. Just be very careful not to abbreviate it as just MOL or MOLE because those are for moles. So we can put that over 1, and we're going to convert from molecules to moles. Now 1 mole of anything is 6.02 times 10 to the 23 particles, or molecules in this case. We can cancel out molecules, and while we're converting to volume of a gas, we know we got to use the 22.4 key. So we're going to get moles of the gas in the denominator, and we're going to put liters in the numerator. 1 mole of any gas at STP is 22.4 liters. We can cancel out moles, circle liters, and you can do the math to verify that you will get the correct answer as liters of SO2. Now for the second one, the second part of this question, notice how we still have to start with number of particles, and we still have to divide by the molar mass, or by Avogadro's number to get number of moles, but we're not going to go toward gas volume. We just did that. We're going to take number of particles, divide by Avogadro's number to get number of moles, and then we're going to multiply by the molar mass to get the mass. That means that I can take this stuff here and I can copy it down here because it's all going to be the same up to that point. But what changes after that point? Once we're in the mole, we are going to still need to cancel out the mole by putting it in the denominator like this, but we're going to go toward the grams. I'm going to specifically add the SO2 here just because it just helps us while we're still learning this to recognize that the molar mass of a substance does depend specifically on that substance. So any gas is 22.4 liters, any number or any particles, Avogadro's number applies, but for molar mass, it is specific to the chemical. The molar mass of SO2 is about 64.1. So you can do the math here, and you can verify that it's going to be grams of SO2 as your answer.